So here where we live in southeastern, south central Pennsylvania, we get weather systems in the wintertime that can give us a whole lot of snow. A lot of my students are always asking me, "Ooh, is this storm going to cause school to be closed tomorrow? Are we going to have a delay?" Well, let's talk a little bit about winter weather in Pennsylvania. There's really 5 major types of snow events that we see here within the state. In almost all those cases, though, the center of the storm, that low pressure system, must pass to our south or east, and we have to be about 150 miles from the storm center for the most snow. So right there we are in Lancaster, and of course we need lots of cold air in place in order to have a storm. So I always look for high pressure sitting somewhere in that part of Canada. That's going to get us a wind blowing around it clockwise, coming down from the northeast. That would be the one path I would look for in storm track, and then this would be the other, or some combination of this is what we really need. And back when I used to teach 8th grade, we would put a big weather map up on the wall. We would have those 2 lines, and we would track every storm crossing the United States. And inevitably, when one went up one of those tracks, we got a foot or more of snow. Here's an example from early in January of 2017. The pink colors that you see there is a winter storm warning. Now, the low pressure system followed that yellow line right there. And notice that even way down in Alabama and Georgia and Atlanta, they had a winter storm warning about 150 miles to the north and west of that line. Right? We had rain close to that line because it was a little bit warmer there, and snow in that band. So here in Pennsylvania, again, we're looking at 5 possible ways to get snow. Number 1, the most common, is called the Alberta Clipper. This is where a low pressure system comes down out of Canada, specifically Alberta, tracks off to our south, and the cold air is in place to give us a quick burst of snow. It's fast moving, and it moves south of us. We typically get anywhere from 1 to 5 inches from an Alberta Clipper. It's usually quite common, especially when we have cold weather in place, because a lot of times this can come down in the Arctic air mass and give us a quick burst of snow. The second kind of snow we can get is from a squall line, or basically a cold front that moves across the state with temperatures cold enough to produce snow. Basically, it's an Alberta Clipper that moves to the north of us, and that cold front comes through some cold Arctic air. Even though it doesn't produce a lot of snow, this is very dangerous. We might only get an inch of snow, but brief blizzard conditions can blow that snow around. And squalls can usually come with little notice, without prior treatment of the road surfaces. So snow falls quickly, and it's usually cold enough to freeze on contact, which causes a lot of accidents. They're rare. They usually only occur in very cold weather here, usually when that Arctic air mass is sitting over the state, usually in the month of January, but you can get it other months as well. January 6th in 2004, on Route 80 up in Milesburg, Pennsylvania, saw a lot of accidents from a very quick moving snow squall. Notice in those pictures, there's not much snow accumulation on the ground, but it fell quick enough and it was in cold enough air that it instantly froze on the surface and created that massive pileup on Interstate 80. The third kind of storm we can get is called a nor'easter. Now in weather circles, we call this a Miller Type B storm. There's 2 types of Miller storms. Notice on this map, we have the high pressure in place off to our north. And then the low moves off to our south and west and then forms along the Atlantic coast and moves up that coastal line. It involves some kind of transfer of energy between the Clipper system and Gulf moisture coming up out of the Gulf of Mexico. It's very hard to forecast these due to the timing of that transfer. That low over the Carolinas basically disappears and then shows up over the ocean in the Gulf Stream. If you miss that timing by an hour or 2, if you miss the speed of the system, if you miss even the location within 100 miles, that's going to change your snow forecast. But usually you can predict that this is going to happen. It's just a matter of how far out to sea that Atlantic low pressure is. Small bands of rain and ice and heavy snow, sometimes up to 2 feet can fall. But you can be in one area with 2 feet of snow and very close to an area of no snow. So it has what's called a really tight snow gradient. So forecasting this is very hard, and the track of that storm is very important. Back in March of 2017, really late in the winter season, we had a quick burst of 9 inches of snow, which came from a Miller B. Notice the path of the low off to our west, which kind of curled up through West Virginia, and then it transferred its energy over the mountains to a low pressure system over the Gulf of Mexico. That warm water fueled a lot of energy, and it tracked off to our east about 150 miles away. They got more snow from this system up in New England, up to 2 feet from northeastern Pennsylvania into the Catskills, up into Massachusetts and Maine. Here is the warning for that system, by the way. Notice all the pink in New England and Pennsylvania, and even some orange, indicating blizzard conditions. That's snow with a lot of wind at the same time. Blizzard conditions were forecasted from Reading, Pennsylvania, all the way up into New England. This is a massive storm for this time of year. But look at Dover in the middle of Delaware, surrounded by a winter weather advisory of some kind. Dover was experiencing flash flooding and rain. That's how quickly the changeover can be and how hard it is to forecast the storm. A second type of Miller is called the Miller Type A. This is the same kind of idea. We've got high pressure in place, bringing in cold air from New England. Then a low forms down in the Gulf of Mexico because the Gulf of Mexico is trying to kill us. So it starts down there and tracks itself up the coast, and then for us, it follows one of those magic lines. It can produce a large area from the southeast to the northeast of heavy snow, anywhere from 8 inches to 2 feet. They're easier to forecast than a Miller B, but the track has to be correct because that rain-snow line is very critical in these types of storms. And they're most common when we transition from the cold months of winter into the milder spring. The fifth kind of snow we get in Pennsylvania we don't experience here in Lancaster, Hempfield, southeastern Pennsylvania. But in the Northwest they get plenty of it. It's called lake effect snow. This is the most common in the state, most dangerous. It's what gives us the most snow. It just never happens here where we live. What happens is very cold air blows over the very warm lake. Cold and warm air together usually produce a cloud. Warm, moist air rises into the cold air. The liquid condenses and it falls as snow. And it falls continuously as rapid, heavy snow, sometimes for hours or days at a time. This is a satellite picture of lake effect from Lake Superior to Lake Michigan to Lake Erie. You can see in that visible satellite picture the snow falling in those bands being blown by the wind. Here it is on radar. The snow from lake effect falls in intense bands that aren't that wide. You could literally have one side of town that gets 2 feet of snow and the other side of town that gets nothing. In fact, here's a picture from Buffalo. Notice some sunshine in one spot and that big cloud, that is snow moving into the city. I once saw this driving on an interstate in New York. I, as a meteorologist, it frightened me to drive into this big wall of white. I went from no snow to 3 inches of snow on the highway, just like that. If you've ever experienced it, it can be kind of scary. And it falls in heavy, heavy amounts. Appropriately, this is the lake effect up in New York. Notice how much snow is falling. You can see it there on the ground. Back in 1996, this is a visible picture in Pennsylvania, Ohio, New York, Ontario. You can see how it falls close to the lake, and as it goes away from the lake, it loses its moisture and the snowfall tapers off. Normal annual snow totals in the region, again, we are around 31 inches, but notice up there in New York, that's called the Tuggill Plateau, where they get well over 100 inches of snow on average each year. To measure the amount of snowfall, we use something called a snow stick and a snowboard. Doesn't sound that complicated, but you need a flat board. You see that in the picture on the left. You stick the stick in through the snow on the board. You take the stick and measure the depth of the snow on the board in 3 places and take an average. Then you sweep the snow off the board, let the snow accumulate on it, and come back 6 hours later and measure again. Now, unlike rain, where we measure the intensity of how quickly it falls from the sky, snow's intensity is measured through visibility, how far you can see in it. This is an example of light snow. That means we can see through the snow well over a half mile. You see it accumulating there on the sidewalk and melting just as rapidly. Moderate snowfall creates anywhere from 1/4 to a half mile visibility. You can see there, but there's also some kind of haze and almost like a fog in the background in the lights. Heavy snow, you can see under 1/4 of a mile. Usually big flakes. This creates a lot of travel problems. Here's 4 feet of snow falling in time lapse. You can see lots of videos like that on YouTube. Now, how you're warned about winter storms coming, there's 3 basic types of advisories. Just like with flash flooding, you have a winter weather advisory first. Not just as giving you a heads up that slippery weather is coming. You might have to change your travel plans in the future. In a winter storm watch, that's saying 6 inches of snow might come in the next 2 to 4 days. You have about 50% confidence of that happening. The 6 inches of snow is for southern Pennsylvania. Depending on where you go, that number will change. For example, off to the south, there might be some areas that will have a winter storm watch under 4 inches, some under 2 inches. Places up towards Buffalo, it might be 8 or 12. It all depends on how they can handle that snow as it falls. After that, we get a winter storm warning. Most warnings, it would be, hey, it's on its way. And while that's the case for most of the people in the warned area, remember a slight change in the storm track might lower your totals or might give you no snow at all. So what the National Weather Service usually does is it will warn a large area and it will say somewhere in there we're going to get 6 inches or more snow. It just might not be you. You might wake up, look outside, there's nothing on the ground and think, I have school under a winter storm warning. So it's not always 100%. The winter storm warning here means 6 inches of snow should come within 1 to 2 days. Notice only the time period changed, not the amount, and not even the word will. The word will is not in there anywhere. Just means conditions are right to get a significant amount of snow. Now, up to 2017, there also was a blizzard warning. And a lot of people think a blizzard is much, much worse than a winter storm. And it is if you're traveling. But it does not, and I repeat, does not mean we get more snow. A blizzard is simply a snowstorm with a significant wind. That significant wind can blow snow around, make it hard to see. It could lower the wind chill, but in no way do you get more snow in a blizzard. In fact, you can have a blizzard with just 1 inch of snow on the ground. If you get it blowing around in such a way that you can't see down the road, you would have yourself a blizzard. With the advent of social media and Twitter, there are some people out there who aren't meteorologists that play the role of a meteorologist. And they will look at any computer model they can to get excited about a future storm. On television, I cannot give you an amount of how much snow I think is going to fall if we're not within 24 hours of the start of the storm. 2 or 3 days in advance, I could say we have to watch this, or this looks significant. but I can't give you an exact number. But the people on Twitter and Facebook have no such restrictions. Here's an example of one in southern Pennsylvania, the S&S. And take a look at that, 119,000 people clicking in. Or the Eastern PA Weather Authority, over 200,000 people tuning in. Why are they doing it? Because they get advertising. They get money if you come to their site and check out their forecast. Forecasting takes skill. Computers often disagree, but untrained people will only key in on one such model. Here's an example from the week of Thanksgiving 2014. Thanksgiving is one of the biggest travel days of the year, so a forecast, a correct forecast, is really important here. The European computer model had a forecast track, look at that brought a lot of snow into Pennsylvania. So the European thought it was going to be rather snowy. So Twitter and the S&S put out this forecast, 6 to 10 inches from West Virginia all the way up through Frederick, Lancaster, Harrisburg, all the way up to northern New Jersey. That's a big deal if you're making travel plans to go to New York or out to the west or down to the south in a couple of days. Here's what actually fell, though, after the event. Only an inch in Lancaster, 2 inches in York. No travel trouble whatsoever until you got to the area where they forecasted 4 to 8 inches. The storm moved a little bit closer than they thought, and it was mostly rain down in Philadelphia, New York City. But if you headed out towards Pittsburgh, you're looking at up to 2 feet of snow. That's a bad forecast. That could affect a lot of people. And usually it's the people on television then that get blamed for the bad forecast that they saw on social media. A good forecaster would not have just looked at the European. They would have noticed in the Canadian that low pressure system was way offshore and there would be no snow whatsoever. The American was kind of in the middle of the road. You could get a couple inches here or there, but you could also get it mixed with rain. And in this case, the American was the one that was the most accurate. This is from the blizzard of 2017, which actually occurred on March 14th. This is the S&S again. Notice it says blizzard conditions over the Susquehanna Valley with higher snow amounts right through the middle, all the way down towards Washington, D.C. Moderate snow amounts all the way down to the shore. Notice they're advertising on this. Here's the snowfall forecast map, again sponsored by a local business. 2 days in advance, a whole day before anybody goes on TV with actual numbers. They beg, we cannot do this alone, we need your help. They used it as an opportunity for you to donate to them. They're making money off of this. Here's the Pennsylvania Weather Action Team using a word crippling for their storm. And this is what actually happened. They did get a lot of snow. They got up to 75 inches in parts of New Hampshire. But here in Pennsylvania, it mixed to rain, basically to our south and east. Hardly any snow down at the Jersey Shore, southern New Jersey. Not that much in Philadelphia, Baltimore, or Washington, D.C. We got about 9 inches in Lancaster. Off to our north, close to 10. Some places got close to a foot as you headed towards New England. Again, putting out a forecast so early, only looking at one computer model, not only is it inaccurate, it's irresponsible. Is it a bad thing? Right, anybody's free to say anything they want. TV meteorologists, though, get blamed when the people on social media are wrong. So it ends up being a great business model. And you have to ask yourself, are these people doing this for the right reasons? One computer model is actually an average of many, many model runs. You're looking at all the model runs for just one of the major computer models. So how do you as a meteorologist express the uncertainty? It's my philosophy, when I'm on the air, I'm going to tell you what weather's going to happen. I don't like saying 50% chance. I'll take a guess one way or the other. But if I'm uncertain, I'm also going to be honest and say that I'm uncertain, because it does happen. The National Weather Service has tried a new approach over the last several years. Starting at the end of 2015, they actually put out 3 new winter products. One of them shows you what they believe the minimum snowfall will be. a certain amount of time in advance of the storm. Then the official forecast is posted, which is somewhere in the middle, but then they also will share with you what they believe the most snow you could get is. What is the worst case scenario? The second thing they've done is they've created these graphs that you can mouse over and see what they believe the chance of getting 1/10 of an inch of snow is. What's the chance you're going to get more than an inch? A chance you're going to get more than 2 inches. This is the way they're trying to combat those people on social media that give one forecast and say, this is what's going to happen, prepare for the worst. The National Weather Service is putting it in perspective, giving you a percentage chance of what they think each possibility will be. The science behind it is there's 57 computer models that are equally weighted. 57 models is the responsible way of forecasting, not finding the one model that's going to give you the most snow and the most clicks on your site. When National Weather Service goes to Twitter, they're going to be more responsible about how they talk about major storms. Here they're talking about the possibility of a heavy snow, which in the end never ended up happening. And this is the message that National Weather Service is trying to get out on Twitter too, that if you see something on Twitter, make sure you don't share it unless you know it's a responsible forecast. Show you care, beware the share. Know your weather person. Understand if they're a meteorologist. Represent your local community well, and just because you can share it doesn't mean you should. Winter storms can be dangerous, especially when it comes to travel. So an accurate forecast is very important. We don't want to cry wolf about bad storms too many times, because then you won't listen when it actually is going to happen. So in weather safety, most people die in their car during a winter storm. So what I recommend you do is you have a blanket somewhere in your car. When I got my driver's license at 16, the first thing that went in my trunk was a blanket. And I actually had to use it in the blizzard of 1993. I was up in Lock Haven, I was driving to State College, and I got stuck. I got stuck on a road that was getting covered in a drift. And it wasn't just me. The snowplow that was in front of me that I was following, they also got stuck. But I had my blanket in the car. I also knew some things about being stuck. When I got stuck, I turned off the engine. And I made sure when I turned it on, about once every 10 minutes, that the tailpipe was clean. The last thing I wanted to have happen was have gas and exhaust back up into the car that I was sitting in, knocking me unconscious. You don't eat snow if you get thirsty. Eating snow puts something cold inside your body that your body then needs to heat up. You're trying to stay warm. So take some snow, put it in a cup, let it sit inside with you, and when it's liquid, drink it. Or better yet, when you turn on the engine, put some on the hood. Let the heat from the engine melt that snow and drink that. Not that most of you watch are going to have to worry about this. The second leading cause of death in a snowstorm is heart attacks. Not because they're scared of the snow, but because these are people who usually don't exercise that much, or they're elderly, and now they have to go outside and do a very physical activity of removing snow. So take it easy. Look out after the elderly and the sick and try to help them out. Now, in other parts of the country with a lot of snow, people have to be aware of something called an avalanche. That's when a lot of snow slides down a mountain and people can get buried. There's a picture of an avalanche coming down a mountain. The snow could move 60, 70 miles an hour. They actually set them off on purpose using dynamite to trigger avalanches when they're prepared to deal with them, rather than let nature take its course when you have a highway running through a mountain pass, let's say. In understanding how an avalanche could kill you helps you understand how to stay safe in an avalanche. Now again, we don't get avalanches around here, but out west they know if they're going to be out in the back country, they report where their location is going to be, where they plan on being. And if there's an avalanche, then people can come look for them if they end up buried. Some places sell a little radio collar that you can put on that they can come and search for you if you get buried. But you don't buy silly things like this for $675. The new airbag system is an avalanche pack. You see the avalanche coming and you pull a cord and these little water wings pop up full of air and you float to the top of an avalanche. But think about it. If you're floating on top of an avalanche at 60 miles an hour and you hit a tree, is that going to save you? No. You've got to protect your organs. The Avalung for $160. If you get trapped, you can stick a tube in your mouth and breathe air out of the snow. Yeah, but again, you're more likely to get killed by a big rock hitting you at 60 miles an hour. The best thing to do is to curl up in a ball. And as the avalanche slows down, you start to move around and create an air pocket and hope somebody finds you. You want to protect your organs in the front of your body, not necessarily float on top of the surface and swim through the avalanche. Here in the United States, when we look at bad snowfall, we need to look at Mount Baker, Washington, the snowiest place in the country. They get 95 feet of snow each year in Mount Baker. Here in Lancaster, we get under 3 feet. Boulder, Colorado has seen the most snow in one day, 6 feet and 4 inches of snow. I'm 6 feet, so it's another 4 inches on top of that. Here in Lancaster, the earliest snowstorm we ever had was just before Halloween in 2011. We got 4 inches of snow. The latest snowstorm was April 20th with 2.5 inches. The heaviest snow we've had in one calendar day was February 12th, 1983, 22 inches in Lancaster. The heaviest storm system we got was in 1996, the blizzard of 96, 30 inches of snow in Lancaster. Harrisburg, by the way, got 30 inches in the blizzard of 2016, but not Lancaster. The least snow we ever got in winter season was 4 inches. That's right. The least we've ever gotten is 4 inches of snow. It snowed every single winter season. That was way back in 1949-50. The most snow we ever got in a winter season was 2009 to 2010, almost 80 inches. We actually had 2 1-foot snowfalls within 3 days of one another. That was quite a winter. Now, in the next video, we're going to take a look at Joe Calhoun, and I asked him about the challenges of forecasting for this region.